Microplastics detected in all human placenta samples. It's been dangerous for us for a while. Plastic has been the cause of many problems, but right now we are truly on the verge of a breaking point. Hello and welcome back to another episode of Focus. This is going to be a really interesting one. You should stay tuned. Microplastics detected in all human placenta samples. A flurry of recent studies has found that microplastics are present in virtually everything we consume, from bottled water to meat and plant-based food. Now, University of New Mexico Health Sciences researchers have used a new analytical tool to measure the microplastics present in human placentas. In a study published on February 17th in the journal Toxicological Sciences, a team led by Matthew Campen, PhD, Regents Professor in the UNM Department of the Pharmaceutical Sciences, reported finding microplastics in all 62 of the placenta samples tested, with concentrations ranging from 6.5 to 790 micrograms per gram of tissue. Although those numbers may seem small, a microgram is a millionth of a gram. Campen is worried about the health effects of a steadily rising volume of microplastics in the environment. For toxicologists, dose makes the poison, he said. If the dose keeps going up, we start to worry. If we're seeing effects on placentas, then all mammalian life on this planet could be impacted. That's not good. In the study, Campen and his team, partnering with colleagues at the Baylor College of Medicine and Oklahoma State University, analyzed donated placenta tissue. In a process called saponification, they chemically treated the samples to digest the fat and proteins into a kind of soap. Then they spun each sample in an ultracentrifuge, which left a small nugget of plastic at the bottom of a tube. Next, using a technique called pyrolysis, they put the plastic pellet in a metal cup and heated it to 600 degrees Celsius. Then captured gas emissions as different types of plastic combusted at specific temperatures. The gas emission goes into a mass spectrometer and gives you a specific fingerprint. It's really cool. Matthew Campen, PhD, Regents Professor in the UNMD Department of Pharmaceutical Sciences. That's a quote. The researchers found the most prevalent polymer in the placental tissue was polyethylene, which is used to make plastic bags and bottles. It accounted for 54% of the total plastics. Polyvinyl chloride, better known as PVC, and nylon each represented about 10% of the total, with the remainder consisting of 9 other polymers. Marcus Garcia Farmady, a postdoctoral fellow in Campen's lab who performed many of the experiments, said that until now it has been difficult to quantify how much microplastic was present in the human body or in human tissue. Typically, researchers would simply count in the number of particles visible under a microscope, even though some particles are too small to be seen. With the new analytical method, he said, we can take it to the next step to be able to adequately quantify it and say, this is how many micrograms or milligrams depending on the plastics that we have. Plastic use worldwide has grown exponentially since the early 1950s, producing a metric ton of plastic waste for every person on the planet. About a third of the plastic has been produced is still in use, but most of the rest has been discarded or sent to landfills, where it starts to break down from exposure to ultraviolet radiation present in sunlight. That ends up in groundwater, and sometimes it aerosolizes and ends up in our environment, Garcia said. We're not only getting it from ingestion, but also through inhalation as well. It not only affects us as humans, but all of our animals, chickens, livestock, and all of our plants. We're seeing it in everything. Campen points out that the many plastics have a long half-life. The amount of time needed for half of a sample to degrade, so the half-life of some of these things is 300 years, and the half-life of others is 50 years. But between now and 300 years, some of that plastic gets degraded, he said. Those microplastics that we are seeing in the environment are probably 40 to 50 years old. Microplastics are already present in our bodies. It is unclear what health effects they might have, if any. Traditionally, plastics have been assumed to be biologically inert, but some microplastics so small they are measured in nanometers, a billionth of a meter, and are capable of crossing the cell membranes, he said. Campen said the growing concentration of microplastics in human tissue might explain puzzling increases in some types of health problems, such as inflammatory bowel disease and colon cancer in people under the age of 50, as well as declining sperm counts. The concentration of microplastics in placentas is particularly troubling, he said, because the tissue has only been growing for 8 months. It starts to form about a month into the pregnancy. Other organs of your body, however, are accumulating over much longer periods of time. Campen and his colleagues are planning further research to answer some of these questions, but in the meantime, he is deeply concerned about the growing production of plastics worldwide. It's only getting worse, and the trajectory is it will double every 10 to 15 years, he said. So even if we were to stop it today, in 2050, there will be 3 times as much plastic in the background as there is now. And we're not going to stop it today. Like I said, Earth is an amazing place. Not just the people, not just the places, not just the animals, but detrimentally to our well-being. It's amazing what we have done to it. But stay tuned for the thoughts and facts section. I really think you're gonna like it. I mean, I'm going to be going slightly out there with my solution to what we could do due to this really serious problem. And it might sound crazy, but it's all factual and it can be done. We do many things. Saving ourselves, I think, is number one. Once again, thanks for tuning in to another episode of Focus. Take care. Okay, so thanks for sticking around for this thoughts and facts section. And where can I start, or where should I start? Let's start with the more concerning part about it. I mean, yes, found in the placenta, but let's start with aerosolized or aerosolization. This is the process or act of converting some physical substance into the form of particles small and light enough to be carried on the air into an aerosol, having the form of a fine spray or colloidal suspension in the air. Example, people walking by these vents can inhale the aerosolized bacteria and fall ill in a matter of days. Or in our case, in a matter of enter time in this slot. Because right now we don't fully understand the process of how this is affecting us. Plastic being aerosolized, being so thin that it can pass through our cell membranes, is more than concerning and alarming. So far, scientists, doctors, medical experts have only determined that it has, or they believe it might be, the reason or the cause for the increased rates of inflammatory bowel disease and other forms of cancer. But the other alarming thing, it is no secret that we, or mothers, pass down, or I can say we people pass down things to our children, i.e. we also inherit things from our parents. Right now, what it's looking like is what we can inherit from our parents is more than just skin deep. And I say that obviously in a very ironic sense, because the plastic is skin deep. But it's for the fact that now when children are born, they are automatically going to be exposed to plastic. And when I say when they are born, before they have even left the safety and the comfort of the womb, they would have ingested to some degree, some form, fashion, manner, shape of plastic. Now, how this can affect or will affect future generations of children being born into the environment, and I'm saying into the environment, but look, long before they even enter the environment, they are facing the dangers. It's bad enough that we can pass over certain blood diseases, and I hate to say it, people can drink and do other things, and these things can detrimentally pass on to our kids. But to know that whilst our children are being born, whilst their bodies, their brains, eyes, ears, nose, vital senses, essential to their well-being, to them surviving, to them living on this planet, on this earth that I love and we all cherish so much. We don't fully understand how this will affect future generations, how it's going to affect the development of an embryo of a child in the womb, which is then going to then double the effect of what this plastic can then do to a child. Depending on where you live in the world, yes, your exposure to plastics is minimum compared to the wider world, cities, major countries, if you have the luxury of living in any of them. The point is, right now, just as they said, the dose says it all. Right now, as we live, we are constantly depositing micrograms of plastic within our bodies through almost everything we drink, everything we eat, and even now, just from the rain falling on our skins or jumping into the ocean and having a bath, you might be absorbing these PFAs or forever chemicals into your skin. So, my question, and like I said, I would have been or might have been going a little out there with my solution to the problem. We have utilized technology in many ways, and right now there is a very defined space race going on. And the technology driving this insane endeavor is even more mind-boggling, and to some people could be classed as impossible. But astronauts survive on the International Space Station for almost a year. whilst getting topped up on oxygen, but the technology on the International Space Station, the rebreathers, the oxygen scrubbers, the air filtration systems, all of these work to increase and maintain a sterilized and breathable atmosphere for them. Now, I know all of this sounds like, what does it have to do with it? Like I said, what we need to do, instead of thinking of building colonies on the moon, building colonies on Mars, and all of these visions we have of what they will look like, why don't we start a little closer to home? Why don't we practice some of these incredible visions, right here? How could it benefit us? Okay, once again, right now we're living in an age where plastic is literally within everything. It has been found on the tallest mountain in the planet, Mount Everest. It has been found in rainfall samples taken across the globe. It has been found at the bottom of the deepest trench on the planet. Plastic. It's everywhere. I've recently seen an article, I have not had the time to read it yet, but I will get around to it, which said it is as simple as boiling water. This could be an easy method to remove, I'm not sure if all, but the majority, or let's say a significant amount of plastic from the water, to make it possible, or I suppose safer to some degree, for us to consume. Okay, but before I go into the radical or extreme solutions, there's still, let's say, two more things that we can still take away from this article. One, the fact that we now have a technology that is capable of detecting to the gram how much microplastics is within our systems. And the other thing is, honestly, don't get me wrong, the decline in sperm counts. Now, the only reason I mention this is because, yes, we have faced diseases, yes, we have faced famine, we have faced drought, we have faced many things on this planet, and we have been able to survive it through the fact that not only we are resilient, not only that we are adaptable, but we can reproduce at, I wouldn't say the quickest rate on the planet, but at a fairly decent rate. So increased numbers in cancers and colon cancer and bowel disease is concerning, yes, but let's bear this in mind. I can't just say we can contribute all the recent influx of all of these cancers to just plastic or just the chemicals associated with plastic. I mean, there are many other things, many other chemicals that are all over the world, and they affect us in many different ways. And even saying that, I mean, it's like this. If we can detect how much, microplastics are in our systems, using this technology, when it's been upgraded a little and the process in which it can detect the microplastics a little more refined, then maybe we can develop the technology that can remove these micrograms or milligrams of plastic from our systems. I mean, I'm saying this because this is a more sound solution to what I'm still yet to discuss. Because right now, using things like keyhole surgery and the fact that we have so many developments in medical devices or robotic, how do you call it, surgeons is the new name for it, but basically robots that can perform certain surgeries to much better degrees that humans can do. Let's say you mix this with AI, because I mean, right now, where this is the world we're living in, everyone's mixing AI with everything in order to get better results, right? So why don't we use it like this? If you could use the robot itself with, contribution from the artificial intelligence software, AGI, whatever you want to call it, it would be a little more precise in the way it can detect or remove these substances. And even then, when I say it like this, obviously certain plastics generate static electricity to a degree. I did hear about a method concerning magnets, I believe, to remove microplastics, and the theory makes sense to me, but maybe something that has a little more static magnetism, electrostatic magnetism, if you catch my drift, just for the fact that it traps the air particles or the dust in the air particles a little more efficiently, right? So that could be one solution. Apologies. But it's more along the lines of, let's say all of this is still inadequate in order to save us. And what I was trying to get at before was the fact that all of these chemicals in the environments have been causing alarming concerns to us for a very long time, and have been leading to more deaths, higher rates of maybe, as it said, infertility, women not being able to give birth. We don't know how many factors are contributing to these recent developments or why it's getting worse. So, like I said, some of these advanced technologies, whilst we look to the stars, maybe we should practice home. I know it's going to sound really crazy, but like I said, what if these technologies we have right now, even all of these technologies we're developing to remove plastics from the ocean, remove plastics from I don't know, food, maybe even the air if we can, water. But what if none of that works? Half-life, 50 to 300 years. So within that time, either we stop creating plastics or create plastics that are a little more safer or more detectable, or use ones that don't break up as fast or break down to that minuscule degree. Either way, I think you might need something a little more, how could I say this? I won't say efficient, but sure. So we want to go to the moon, we want to go to Mars, we want to colonize other planets. Depending on where these places go, because right now we have not found a planet that contains oxygen. We keep looking to places that has no air, no environment, no background for a sense, if you understand what I'm saying. So what if you built these micro biomes, environments? I won't say they will be sterile. They would contain everything a normal habitat would have, and I don't mean habitat as in a habitation for a person, I mean as in the wildlife. So a self-contained ecosystem. Does that make sense? It kind of does to me. I know it's extreme, I know it's out there, but think about it. Between declining sperm counts, us not reproducing as or having as many offspring, the amount of unknown illnesses that are also affecting us, the increase in known illnesses that are affecting us, maybe a more like I said, not exactly sterile, but a more sterile way of living should be considered. And let's even think about it like this. If you did have to create an environment like this, I'm not proposing anything small either. Not something that would just hold, how could I say it, one family or two or three. I'm proposing a significant amount of any population who's willing to achieve this, to take part in this, would be eligible. And just so you can truly understand what I'm saying, it would be similar to the Martian astronauts or the moon astronauts, the ones who are currently running a 1-year simulation in the desert. So right now they are in a habitat, not exactly a dome. It hasn't got the right amount of windows to allow vegetation to grow on the inside, but they are more or less transitioning into a life of solitude, of isolation, of like I said, I wouldn't say more sanitary, but you understand what I'm trying to say. More sterile. Not free of germs and bacteria, because the addition of the habitat, environment, a working ecosystem. So water would be coming in, and what I do propose is that these domes would have to be positioned near to a water source, because even then, like I said, the method of maybe boiling the water to remove these microplastics, imagine water flowing into these large domes and it being heated up in some area, some form, some fashion, creating the vaporization, the condensation, even the slight illusion of a cloud on the inside, enough to create the atmosphere that the plants would need to survive. And in doing so, you would be, to a degree, keeping it sterile, because whilst the water's coming in, like I said, using some of these great technologies that are used on the international space stations and submarines, by the way, this could decrease the amount of plastic being, how can I say it, admitted into each dome, reducing how much plastic is theoretically passed on to each person. And now, thinking about it like this, if each one of these has a isolated reservoir of water, let's take for example one of these isolated lakes that may or not have been from the Jurassic period or Cretaceous period, or whichever one you would like. Either way, one with any luck that has not been polluted or has as little PFOs or PFAs or perfluoric acid compound acetate. You know what I'm getting at. Microplastics, plastic. And then you could possibly create an environment where people could have offspring, where the amount of plastic they pass on to their children, the amount of plastic which they consume, will be reduced. Now, I've only spoke about it on one way. Now, I'm not proposing we turn into, I don't know, nomads, we live off the land, but we need to find some sort of balance. And I'm not saying that we need to isolate ourselves in these environments without, I don't know, the comforts, creature comforts, as people like to say. I'm proposing that we move towards something a little safer. A combination of materials that are less plastic based, less oil based, I mean, metamaterials are making a splash in the industry right now, but let's give it a little while to see how that goes. I was looking at a non-linear crystal formation. Either way, they wanted to use it for optical purposes, but structural, regardless of the fact that it can bend light, would seem sound. Because a structure that can heal itself or grow under certain conditions would be more ideal for these structures, because obviously wear and tear, earthquakes, hurricane storms can cause damage. Structures that can partially heal themselves to some degree at least could be the answer. And the reason I'm saying this is, and I suppose I left it a little late, is because, like I said, half-life 50 to 300 years. So yes, what I am proposing is, for the benefit of the species, for humankind, that some of us opt in for this life. And the only reason I say this is because we don't know how this is going to affect us. We have seen slow signs, evidence leading in directions, but no confirmation as of yet. Although I did read another article, but that's for another episode. It would be for a really long time, 300 years. So think about it not only as saving the species, think about it as the ultimate, and I hate to say it like this, but experiment, test of wits to see whether or not we could survive under these conditions. Now bear in mind, I'm not saying they're going to be isolated. Influxes of certain goods and materials will be a must. What I would like is if these influxes of goods were plastic free. So how can I say this? A rethink of certain, how can I call it, manufacturing capabilities. I know it's going to sound really crazy, but let's just say, for example, instead of having and I know it's going to sound out there, but just hear me out. Instead of having a plastic frame or plastic base around certain TVs, I mean, wouldn't be too crazy. Less plastics to infect or break down within that environment. Obviously, I know the components for the television will still be there, but yes, it would be reduced. And I don't know, you can use glue, or honestly, tree sap. You know where glue actually comes from, right? It actually comes from a tree. The original glue from those trees is pretty strong. And I mean seriously strong. Crazy glue came from somewhere. But you could use that to seal it, and it would create some kind of insulation around wires as well. I mean, it's out there, but sometimes a simple solution, a more basic solution to a big problem can actually make sense. And obviously they won't be as resilient, they won't last as long, but like I said, the reason why, and this is just me giving an example on that, but I'm digressing. I don't want to go into daily life of what it would be like. I mean, I'm pretty sure if you wrap your head around the idea I'm pitching to you here, you could understand it. It won't be easy. It could be nice, but it could save our lives as a species. So let's say if in 300 years' time, cancers are rampant all over the world, people giving birth slim to none, probably hailed as a true miracle. And then our population might be in decline. I mean, it's happening all over the world already. Japan is facing a real problem in a couple of years' time. So, what do you think? I mean, like I said, it's a real out there thought. But in the grand scheme of it all, I think it's a feasible solution. I mean, come on. Greater minds than mine think the solution to a problem or this problem is that we need to be living on other planets, reaching out throughout the stars in order to give our species a better fighting chance on the rare occasion a supernova, a gamma ray, or, that old-time favorite, an asteroid comes our way. So I think living in domes isn't that bad of an idea. I mean, right now we're considering underwater habitats all over the world. There's a really interesting one in the UK. I think it's at the bottom of a quarry. That's another interesting episode I've got to let you know about. But like I said, it's out there, but I think it's possible. Actually, I know it's possible. The technology we have available to us today, we can build mile-high skyscrapers. Building a dome a mile high and wide wouldn't be that hard. Vice versa. Have you heard? Scientists want to save the Doomsday Glacier by building, I think, a 65-mile long wall underneath the water to protect the glacier. I mean, a 65-mile long wall opposed to a mile-high dome, mile-wide. I mean, not saying it doesn't sound possible, but it doesn't sound impossible. Like I said, Earth is an amazing place. I'd really like to keep it like that. Don't you? Thanks for tuning in to another episode of Focus. Take care. And thanks for more than just a moment of your time. See ya. For links to the articles, check out the episode description. If you want to leave a comment, check out the trailer description for the email address. For topics like these and more, check out future episodes. Like I said, the world is an amazing place. There's a lot going on, and sometimes we just need to take a moment to focus.